we present our final year project research.
Assalamualaikum and good evening to Madam Zarina. Okay, before anything else, I will introduce myself and my group members. My name is Nur Akmal binti Ahmad Zukri.
My name is Ahmad Aizuddin bin Muhammad.
And the rest.
My name is Anishaira binti Ahmad Nizam.
My name is Miza Kadina binti Zamri.
Process safety accident analysis of chemical industry. Our final year project for this year. Okay. And our supervisor is Encik Muhammad Fidaus bin Hussein. First of all, this is our content for our discussing. First, introduction. Second, problem statement. Third, objective. Fourth, methodology. Fifth, findings. And the last one is conclusion. Introduction about our project. Many industries are built up around the world, but for safety accident analysis, that we only focus on 4 types of plant, which are refinery, petrochemical, upstream, and gas processing plant. We are reading 1998 until 2018. This industry is in very high demand to make a chemical-based product, and it also produce product from those chemicals via domestically and to the worldwide. But there are many accidents that occur that lead to the both large and small loss in the chemical industry. 80 accidents we studied and 20 of accident of each plant for this case study. For general main hazard, which are explosion, fire, and toxic release. Okay, the main contributor that lead to the accidents such as organizational error, individual error, technical error, and the last one is design error. Furthermore, lack of understand information of legislation also can contribute to the accident. And the accident that happen in major loss generally occur because of the failure of number of the system or barrier within the process safety management system. Therefore, all the accidents occurred may lead to the damage of equipment, environment, and affected to the large scale of health, welfare, and employee. Next, the problem statement. Lack of understanding and information on the what event that can contribute to the accident may later result in the future similar accidents. Second, for several years, many reports of accidental release of flammable liquid and gases, reactive substance, and toxic substance have been recorded in operations containing and cause injury. Next, the objective. First, to study the accidents in a few types of chemical process industry within 1998 until 2018. For example, the study on the accidents occurred in petrol and refinery plant around the world within 1998 until 2018. Second, to identify type of hazard to be occurred. Chemical process hazard can be associated with consequence outcome of fire, explosion, release of toxic substance, or combination of all these hazards. Third, to identify, classify, and rank accidents contributors and determine the origin of their root causes. Root causes analysis important in order to get the underlying cause of the harm from the accidents occurred. There are the different types of root cause, whether it caused by human contributor, such as organizational error or individual error, or equipment contributor, which are design equipment error or technical equipment error. If the root causes of an accident are not identified, only superficial solution can be considered. The hazard. A priority ranking for low risk. Okay, next we go to the methodology for our case study. In this study, the methods broadly into quantitative and qualitative methods in order to produce a richer and more comprehensive understanding of research area. And then the scope limitation for our case study, the company that we study are the components that we study are 7 factors, which are type of equipment, process, hazards, process condition, and other accident contributor that lead to the catastrophic accident in the process chemical industry that mentioned earlier. And we will discuss more the accident contributor in the next slide. Okay, this is our framework accident analysis procedure. First, we perform the research for the existing plant based on the 1998 until 2018, which are 4 types of different plant: petrochemical, refinery, gas processing, and upstream. This total research consists of active accidents that happen around the world. And then, each student perform the research for the 20 different existing accidents for the chosen plant based on the 1998 until 2018. And then we identify all the location for the accident, especially for this involving extreme sport. Okay, as you can see, the blue box, this is the highlight for our research. First, when we collect all the journal or article for the accidents, first we identify the type of hazard, then identify the type of equipment, identify the type of hazard, identify of chemical that involved in the accident, and then identify the process condition involved, which are temperature and pressure involved, which is in high or low, and then identify all the accidents contributors such as human error, which are individual and organizational error, and then the equipment error, which are design and technical error. And then the last one is recommend the safe or preventive measure in order to prevent the similar accidents in future. Okay, next, the findings of our case study. First, type of equipment, type of process. Third, NFPA of chemical. Fourth, temperature. Fifth, pressure. 6 types of hazard, and 7 accidents contributor. So next.
Yes. Okay. So for the next slide is equipment involved in process chemical industry from 1998 till 2018. So next slide, please. Next slide. Okay. So based from the table on the analysis of 80 accident, the result shows that that the tank have higher possibility, which is around 21.51%, to occur accident in chemical plant, followed by the piping, reactor, process vessel, and compared to the other equipments. And these are the common equipment that cause an accident in chemical plant. So why is this happening? So most of the company follow the standard and guidelines either in design, construction, and operation, but only certain company are done. And this is why tank accidents still occur for the first place in chemical plant. And why is this happening? This is probably because of the minor mistake that lead to a major accident in tanks, such as a tiny hole that lead to a liquid leaking from a tank and cause a big explosion. Some company also does not follow the safety regulation from the local safety institution, especially during inspection and maintenance works, or no maintenance works or regularly inspection are done at all. Also, next is we can see that the authority doesn't care about the condition of the tank, or the tank has been used for a long periods of time. So next. Next slide. For instance, like accident at Patrice Ralph Smith County. For instance, like accident at Patrice Ralph Smith County oil field on June 5, 2006, where 4 workers were installing a pipe within 2 tanks, and their welding sparks and ignite a flammable vapor escaping from an open pipe about 4 feet from their welding activity, and caused an explosion at the tank and killed 3 people who were standing on tops of the tank, and the 4th one was seriously injured due to the explosion. And next example is from the MGPI processing accident in Kansas on October 21, 2016. It is about 4 years ago, where a truck driver wrongly connect a pipe which has sulfuric acid, which contains the sulfuric acid, connect to the sodium hypochlorite and produce a cloud containing chlorine and other compounds. So why they doesn't want to repair or fix this? Because this company actually disobeyed the safety order, because they know that the safety regulation during maintenance works or operation will cost them a lot. Although that they have made so much money from the production, they still doesn't want to spend their money to repair or fix the broken parts in the tank. So like end oxidizer, storage, conveyor, raffinate, and splitter share the least possibility equipment to occur accident in chemical plant. This is probably because of this equipment is not really a major and a big equipment in chemical plant. So the operator can easily check on them and check the efficiency of this equipment. Okay, next. So next is process chemical industry from 1998 till 2018. So next. So there are lots of processes happen in chemical plant. Most of the accident that happen in chemical plant, which is when the chemical substance is being handled or in processing. And from the result, mixing process is the most recorded process that happened in incident in chemical plant, which is around 13.58%. This is probably because of the incautious action, incautious behavior by the operator during controlling the flowing liquid, and cause the liquid mix with the wrong substance, or wrongly connect a pipe and cause an accident in the plant. Like example, I use this now, like in NGPI, where accident on 21 October 2016, where a truck driver wrongly connect a pipe and cause a cloud vapor. And next slide. And next slide is corrosion from the pipe and react with the substance that flows into it. On the previous slide, I picked one example from Chevron Richmond accident in California on July 6, 2012, where a rupture of the four side crack piping resulted from 52-inch component being extremely thin due to a damage mechanism known as sulfidation corrosion. It is also known as sulfidic corrosion. It's the damage mechanism that causes a thinning in iron containing material, and such as steel. And due to the reaction between sulfur compound and iron at temperature ranging from 450 Fahrenheit till 1000 Fahrenheit. And the leaking pipe from the accident was identified to be the portion of the four side pipe piping. And the engineer concluded that the leak was not significant enough to require a shutdown. So they immediately repair, and unfortunately it goes back, and a white hydrocarbon vapor visibly began to emerge. And the last one is the chemical properties, weather and surrounding, like on the previous slide. And I picked one example from Pratt's Air Facility accident on June 24, 2005, where St. Louis was experiencing a heat wave with bright sunlight and a temperature around 97 Fahrenheit, where cylinders suddenly explode and spread a fire across the area. So most of the accident would have been avoided if a good engineering have been practiced, such as good labeling, and operators should be more alert about the content of each equipment in the plant. Okay. Next.
I will continue the presentation. So I will talk about the NFPA of chemicals. NFPA stands for the National Fire Protection Association. As you can see, this is a visual of the diamond, how NFPA looks like. And there is 4 types of hazard. First, health hazard. Second, fire or flammability hazard. Third, stability or reactivity hazard, and specific hazard. This study we will focus on the health hazard, fire or flammability hazard, and instability or reactivity hazard. In order to handle certain risks, industry has recently revised tools in the form of guidelines issued by NFPA. Next. In 80 accidents that we have studied in process chemical industry, the chemical that most frequent involved in chemical accident, which was methane, the total NFPA of methane is 6, and which is health rating is 2, and the flammability rating is 4. In the upstream plants, 5 accidents involve the methane chemical, refinery 2 accident, and for the gas processing is 1 accident. For the left hand side, this show the more details on the chemical that involved in each plant. And as you can see, the petrochemical have the max NFPA, which is 10, and for the minimum NFPA, we have 2 types of chemical, which are sulfur and sugar dust. Next. The NFPA maximum is belong to the ethylene oxide. The example accident that involved ethylene oxide is Ontario, California, that happened 19 August 2004. The explosion happened in the ethylene oxide sterilization facility. The ethylene oxide that used in the facility is to kill microbes by disrupting life-sustaining molecules. The head rating for the ethylene oxide is 3, flammability 4, reactivity 3. The head rating for the ethylene oxide brings serious risk of the chemical burns to body tissues. If a device such as medical product sterilized in the ethylene oxide is not aerated, which was aeration cycle after the sterilization cycle to allow the ethylene oxide absorbed during the cycle to elute medical product. After that, this medical product will contact with the people and bring serious risk. Second, high flammability. Ethylene oxide poses an exposure hazard as it easily and completely vaporizes in the natural ambient temperature and atmospheric pressure. That strong initiating source is required. It is explosive decomposition. The ethylene oxide will decompose when the temperature at 932 degrees Fahrenheit. In this facility, before the accident happened, the ignition of ethylene oxide and mixture took place before the oxidizer could be shut down. It showed that the ethylene oxide, how fast the ethylene oxide will explode if it reached the ignition source. Next. The effect from the explosion, worker may be at risk of death or serious injury. If safe operating procedures are not established and followed in large-scale industrial processes that use ethylene oxide gas for sterilizing medical devices and other products. How to prevent this kind of accident happen that involve the ethylene oxide is regular preventive maintenance. Second, ethylene oxide concentration in the sterilization chamber should be monitored before bad vents are activated. Exhausting ethylene oxide in chamber to emission control device. It can be concluded that monitoring is needed to avoid exhausting high concentration ethylene oxide. Next. As I mentioned before, that an APA minimum have two type of chemical that involve with the same value, so which are sulfur and sugar dust. For this slide, I will talk about the sulfur first. For the head rating of the sulfur, which 1, permeability 1, and reactivity 0. The accident that involved the sulfur chemical is Chevron treatment on August 6, 2012, where the fire hazard happened. The dust particle may be irritating to the eyes, nose, throat, skin, and molten sulfur can cause thermal burn. The sulfur may be emitted by friction, static electricity, heat, spark, or flames. Toxic gases will form upon combustion. For example, burning sulfur can produce the sulfur dioxide. As we know that the sulfur dioxide is a toxic one. Why this accident happened? Because Chevron not effectively implement internal recommendation in pipeline in order to prevent the pipeline failure due to the sulfidation corrosion. And how to prevent this? The operator need to examine potential corrosion and use safest possible construction materials. Next. And the last one is sugar dust. Head rating 0, flammability 1, and reactivity 1. The example accident that involved sugar dust in Georgia on February 7, 2008. When sugar dust in a dry or dusty form, sugar poses a combustion threat. Second, sugar dust meets with air together in a confined space to form catastrophic explosion. And why this accident happened? Due to dust accumulate on an explosive concentration inside the enclosure. When the enclosed the carrier belt with the stainless steel clumps of sugar were found blocking on the discharge chute. This sugar dust will contact the ignition source. How to prevent this? Housekeeping measure needed and or strict maintenance practices needed in preventing combustible liquid, compressed gases, and dozens of other unstable and reactive material for initiating a disaster. Next. The next one is a temperature involved in process chemical industry 1998 to 2018. Next. The right hand side is a graph on the temperature involved in process chemical industry accident 1998-2018. As you can see, there is a consist of GP, R, T, and U. It can be classified as a gas processing, refinery, petrochemical, and U for upstream. For the left hand side is a more details on the temperature minimum and temperature maximum for each plant that we have studied. Next. For the left hand side, as you can see, there is a high and low temperature, but it is not problem because from our study, either low or high temperature in the process chemical industry plant still causing the accident that damage the building, environment, injuries, and cause death of people. Most of the accident happen in process chemical industry caused by runway reaction due to plug locking and the safety devices failure and lead to the explosion, fire, and toxic release. Operators should be more alert with the temperature because temperature can change anytime and hard to control. As we know that the temperature can easy going up and down, and at the high temperature, particle can collide more often and with more energy, which make the reaction take place more quickly. And it can be classified as a runaway reaction. Next. For this slide, I will explain about the temperature maximum and temperature minimum for process that involve in process chemical industry. First, temperature maximum is 2000 degree Fahrenheit. The example accident that involved this kind of temperature is Washington State, USA on June 10, 1998. The accident happened due to the pressure relief valve fail and rupture of brick gasoline pipeline and leaks to the high temperature. In this accident, before discovering a source of ignition and catching fire, the gasoline from the pipe flowed down the river creek for about 90 minutes and spilling 237,000 gallons of strong odor of gasoline when the gasoline vapor exploded. For the temperature minimum is 110 degree Fahrenheit. The example accident that involved this kind of the temperature is Gulf of Mexico 2015 where the fire has happened. The accident happened due to the corrosion of small bore pipeline. As you can see that two types of accident that I mentioned like just now is due to the pipeline failure. In order to prevent this, the company need to improve inspection, prevention practices. For example, improve pipeline testing. As we know that many pipelines are decades old and they have been inspected since they were first put into the ground or somewhere else. The company must ensure pipelines are properly tested for corrosion, leak, or another problems. Next.
Okay. So next is pressure involved in process chemical industry from 1998 to till 2018. Okay, next. So according to the table, as according to the table that most accident that happen in chemical plant is because the most highly pressure is recorded in gas processing plant, which is 30,000 psig, followed by the upstream 18,000 psig, and the petrochemical 2,000 psig, and refinery 1,300 psig. So most of the accident that happen in chemical plant is because of the overpressure in the equipment that lead to explosion, toxic release, and other hazards. So the operator should be more alert about the condition of the chemical composition, especially the pressure, because pressure is a very fragile or very volatile to handle. They can easily go ups and down within a second, and every little change in pressure can cause a different product. So the higher pressure in gas processing, so the greater safety precaution step need to be looked. So on the next slide is like example like I picked from NDK Crystal accident in December 7, 2009, where a state vessel number 2 under an operating pressure of 29,000 psig suddenly and violently ruptured, and because it sit till 30,000 psig, and white clouds of steam and debris rapidly expand outward from the facility and travel onto the interstate and dissipate within a second, cause one death and one injury due to the flying fragment propelled by the force of the vessel explosion. So first, how to prevent this? So first, the operator need to have a knowledge and a proper training, because a necessary training must be given to those who are responsible for repairing, maintaining, installing, or checking the pressure at all time of the equipment. So we cannot afford to let a person with a little knowledge about the equipment to handle it. Second is the operator. The operator must understand the operating condition, and this is actually the most important thing in pressure, because they should have a proper understanding about the gases or liquid contained in the pressure vessel. Is it toxic or is it a flammable gas inside the vessel? So once they know the content of the pressure vessel, they also need to know the operating condition, which is include temperatures and pressure, because pressure may exceed the limit and cause an accident and destruction to the building, facility, and even worse death. Okay, next. So for the hazard, next, hazard involved in process chemical industry. So according to the pie chart, explosion is the most hazard that involved in accident in chemical plant, which is around 40% compared to the other hazard, followed by the fire, toxic release, and blowout. So the least value is from the mechanical failure and chemical release, about 0.93%. Hurricane, leak, and collision share the same value, 1.87%. And there are actually three main elements that combine to create a plant explosion, which is heat, the creation of gas, and a dangerous reaction. So in order for explosion to occur, chemical must generate a large amounts of gas within a short amount of time. Often the chemical involved in explosion will become explosive when they come into contact with the oxygen in the air. And when a chemical produces large amounts of gas in a short time frame, even those that are not generally explosive can generate an explosion. The most common factor is heat and dangerous reaction are the cause of many plant explosion. So gas leak, often caused by the poor maintenance, and result in numbers of explosion every year. So when gas leak comes into contact with source of heat, they begin to expand and explode. Sometimes the plant will dissolve. Sometimes plant explosion are caused by the use of impure chemicals. So what is impure chemicals? Impure chemicals like water with dissolved oxygen is not a pure substance, as it is contain molecules of two kinds, which is hydrogen and oxygen. So it is impure chemicals. So for the impure chemicals may produce large amounts of gas, which can trigger a dangerous reaction and ensuing explosion. Next. So for example, in I pick example from the Goodyear heat exchanger in Houston, Texas on June 11, 2008, where accidents were caused by the heat exchanger rupture and explode. It began with the operator closed the block valve, isolating ammonia, control pressure valve. Then suddenly the pressure in the heat exchanger shell suddenly climbing and until it violently ruptured. And the catastrophic rupture through debris that struck and killed one Goodyear employee walking through the area. And the rupture also released ammonia, exposing five people nearby workers to the chemical, and one additional worker was injured while exiting the area. So why do we need to overcome this? And first of all, because our main priority is to save life. It is to save life, the worker's life, especially for the one who is working inside the plant, and all the life surround the area, including the people and the environment. And the second is to ensure that it won't ignite, it won't cause or ignite other equipment to explode. And the last one is to keep supply product for the customer, as well as to look after the company reputation. Next.
The last factor that we have studied is accident contributors involved in process chemical industry 1998-2018. Next. The left-hand side is a more details on the total of each area for each plant that we have studied. And accident contributor technically oriented, including human error and equipment error that lead to the accident. And this kind of two types of error will divide to the specific one. Is for human error will divide to individual error and organizational error, and for the equipment error it will divide to design equipment error and technical equipment error. Previous slide. In the 80 accident that we have studied in process chemical industry, 180 causes to the accident were found. Typically, there are also more than one causes that lead to the accident. For the right hand side is more details on the percent of the each error that we have studied. So I will classify it Individual error contribute 21.11%, organizational error 27.22%, design equipment error 24.44%, and for the technical equipment error, we contribute to 27.22%. Next. The most common causes were caused by the equipment error, where accounts 93 causes, while the equipment error is a high have a high percent of the from others. First, no preventive maintenance, and second, no inspection equipment. From these two issues, probability company did not want to spend more money on model because they think the maintenance costs are so high and it can safely curb the profit margin and prevent the company from success. But actually, it is a not right decision because we know that if equipment failure, it can cost more than maintenance cost. It is because the breakdown causes production to stop. The costs are very high because no parts are being produced. Next. The high causes in the types of error, which is equipment error, is belong to the technical error, which accounts 49 causes and contribute to 27.22%. This kind of technical error may be happen during the manufacturing processes. The example of the technical error is improper control system, safety devices, or system failure. This is because no regular maintenance check. Chemicals injuries caused by technical error should be not ignored because if it happen, it may be damaging the building, injury people surrounding. For example, if the cooling system in reactor was failure and at the same time the backup cooling system also failure and not occupied, so it can lead to the runaway reaction where the temperature rising rapidly. As we know that the reactor involve the reaction and involve the high temperature. And after that, when the temperature rising and no cooling system to prevent this kind of the runaway reaction, of course the reactor will be explode as the greatest one. The example accident that caused by the technical error is Washington State, USA, June 1999, due to the pressure control valve and the insulation valve were not operational. How to prevent this? Individual reactive processes needs its own hazard recognition in order to evaluate an effective prevention and mitigation framework that affect both process design and equipment decision. This option depends on various factors, including process parameter, inputs, processes, and machinery, the numbers of the possible release and impacts, as well as a potential exposure to human and the environment. And the last one is preventive equipment failure. Next. For the last one is organizational error that have a high percent from individual error, which accounts 49 causes and contribute to 27.22%. The example of the organizational error is lack of the work permit, lack of awareness of hazard or knowledge in chemical reactivity, improper analysis of hazard, lack of attention, simply error or inadequate training, lack of control of chain procedure. As we know that the human error is very hard to control. The example accident that caused by the organizational error is Ontario, California, that happened in August 2004. This is because technicians bypassed the time consuming gas washers because they believed that there were no product in the chamber. And they did not realize that about half of the ethylene oxide originally injected still remain in the chamber. How to prevent this? Perform job safety analysis, operational procedure, and safety training to ensure compliance in chemical plants in order to prevent chemical caused by the human error during repair, maintenance, and normal operation. That's all for the factor that we have studied. So, next.
Okay. For the conclusion, next, okay. This case study performed an analysis on a catastrophic hazardous chemical accident involving a domino effect, focusing mainly on its process, condition, consequences, causes, and accident contributors. Okay. Second is this research gives a good lesson, such as it gives the knowledge about the process safety analysis accident. Okay. It is because well-managed accident database with a sufficient number of meaningful accident providers of multitude of information and resources for addressing hazard. Okay. There were accident in chemical industry, which consists of 7 factors, were observed that can contribute to accident. So next. Okay, based on the analysis of active process chemical industry accident, the results show that tank have higher possibility, which is 21.51% to occur accident in process chemical plant, while explosion account for 43% of the accident. So per accident contributor divide by 2, which is first human error and second is equipment error. Okay, for human error is more to organizational error, which is 27.22%, and for equipment error, which is more to technical error, which is 27.22%. Okay, so based on the result, it can be concluded that routine safety precautions are key. Okay, so next. Okay, there were 3 safe or preventive measures in order to prevent the similar accidents. Okay, first, next. Okay, first, manufacturers should be proactive in order to evaluate potentially products dangerous. In order to determine safe storage condition, monitoring for real condition and elevated temperatures during storage should be carried out. Okay, second is hazardous chemical storage facilities should establish standard operating procedures for storing and handling materials that resolve storage restrictions. Okay, last is installation that store, use, treat, produce, or transport hazardous materials should create and enforce a system to assess the possible hazard of changes to installation, facilities, chemicals, technologies, and processes. Okay, next. Okay, other than use safety and preventive to measure the accident, company also can follow chemical safety legislation in Malaysia to avoid accident. Okay, such as it has 4 safety legislation. Next. Okay, which is first, OSHA control of hazard industrial, control of major industrial hazard. Regulation 1996. Okay, the function is to prevent major accident and to limit the consequences to people and environment. Okay, second is OSHA use and standard of exposure of chemical hazardous to health. Regulation 2000. Okay, the function is to control exposure of chemical hazardous to health to the worker at the workplace. Okay, third is notification of accident, dangerous occurrence, occupational poisoning, and disease. Okay, Regulation 2004. Okay, the function is to notify, report and keep record of work related to accident, dangerous occurrence, occupational poisoning, and occupational disease that had occurred at the place of work. Okay, last is OSHA classification, labeling and safety datasheet of hazardous chemical, regulation 2013. Okay, the function is to provide sufficient information on hazard of chemical that supply. Okay, so that to mitigate the risk of accident happening in the workplace, thus providing a safe and healthy working environment and condition. Okay, lastly for recommendation. Okay, for recommendation, you do another research on process chemical industry plant around the world, such as nuclear power plant, terminal distribution plant, plastic and polymer plant, and metal processing. Okay, this future research will give more knowledge about safety. Okay. The future research is to figure out the property damage of losses for the company, such as equipment damage and building damage. Okay. Next. Okay. That's all from us. Thank you.
Thank you, madam.
Okay,